Welcome back. Today, we're going to explore how to implement the latest NIST Cybersecurity Framework. This is going to be a beginner-friendly, step-by-step walkthrough designed to help you understand what NIST CSF is, how it works, and most importantly, how to apply it using both Microsoft and non-Microsoft tools. Let's get started. Let's start with the basics. What exactly is the NIST Cybersecurity Framework, or CSF? The CSF is a set of best practices and guidelines developed by the U.S. National Institute of Standards and Technology to help organizations manage cybersecurity risk. It's flexible, scalable, and can be used by any organization, big or small. Think of it as a common language for managing cybersecurity risk. It helps technical and business teams stay on the same page when it comes to protecting information and systems. You can download the official NIST CSF 2.0 guide from the link in the description below. Before we proceed with NIST CSF, I would like to quickly talk about NIST SP 800-53. NIST SP 800-53 is essentially a massive catalog of cybersecurity and privacy controls. SP stands for Special Publication. It goes into far more technical detail than the CSF and is used by U.S. federal agencies. But many private organizations and other cybersecurity frameworks also use it as a reference. You can check out the official NIST 800-53 special publication from the link in the description below. Think of NIST CSF as the strategy and NIST SP 800-53 as the playbook. For example, the CSF says implement access control. SP 800-53 tells you exactly what that means, like how to manage accounts or enforce MFA. This table provides you an overview of how NIST SP 800-53 relates to NIST CSF. You will notice that NIST SP 800-53 has over 1,000 controls. And no, you don't need to implement every single control. NIST CSF is not a compliance standard. It's a risk management framework. That means there's no official certification or external audit body that declares you NIST CSF compliant. The goal is to use the CSF as a flexible guide to select controls that make sense for your business risks, size, and industry. The latest version of NIST CSF 2.0 is a big step forward. It includes updated language, a stronger focus on governance, and it's now applicable globally, not just for critical infrastructure. What makes it so valuable is that it aligns with other major standards like ISO 27001, SOC 2, and even the Australian Essential 8. So if your organization follows any of those, you're already halfway there. NIST CSF 2.0 helps you connect your cybersecurity work directly to business goals, and that's a big win for executives and tech teams alike. There are 6 core functions in NIST CSF 2.0. First is govern, second is identify, third is protect, fourth is detect, fifth is respond, and sixth is recover. You can think of them as a continuous cycle. You set governance and strategy first, identify what needs protection, put safeguards in place to protect those assets, detect threats, respond when incidents happen, and recover effectively to restore your systems and infrastructure. Every organization, no matter the size, can build its cybersecurity maturity around these 6 functions. One of the biggest updates in NIST CSF 2.0 is the addition of the govern function. Governance is all about leadership, accountability, and decision-making. It sets the tone for the entire cybersecurity program. This is where policies are defined, risk tolerance is set, and oversight is established. Without good governance, even the best security tools can fail because there's no alignment between people, processes, and technology. Governance includes several key areas: your risk management strategy, defined roles and responsibilities, and policies and procedures that keep everyone accountable. It also covers legal and regulatory compliance and supply chain risk management, something that's become a huge issue with cloud and third-party providers. The goal here is simple. Make sure cybersecurity decisions support business priorities while meeting compliance requirements. Now, if your organization runs mostly on Microsoft technology, you've got a few powerful tools that can help with governance. For example, Microsoft Purview Compliance Manager helps you track regulatory compliance. Intra ID lets you manage roles and enforce least privilege access, and Defender for Cloud helps apply consistent policies across your cloud resources. These tools make governance measurable, not just theoretical. For non-Microsoft environments, there are great options too. Tools like ServiceNow GRC and Archer help automate governance workflows and risk tracking, while Vanta simplifies compliance documentation. And if you're just starting out, even something like SharePoint or Google Drive can serve as a structured repository for your security policies and audit records. The important thing is to have centralized visibility and accountability. Once you've got governance in place, the next step is understanding what assets, systems, and data you need to protect. This is about getting full visibility across your environment. You can't secure what you don't know exists. During this stage, you'll build an asset inventory, understand your business processes, and start identifying key risks that could impact your operations. The Identify function covers things like asset management, business environment, risk assessment, and supply chain risk management. Together, these help you answer key questions. What assets do we have? Where is our critical data? Who are our key partners and vendors? And what risks do we face if something goes wrong? Once you can answer those questions confidently, you're ready to start protecting those assets effectively. When it comes to identifying what you have, Microsoft gives you a big head start. Tools like Defender for Endpoint automatically discover devices on your network, even unmanaged ones. Azure Security Center gives you an inventory of your cloud resources, and Microsoft Purview Information Protection helps classify and label your data so you know where your sensitive information lives. These tools make the Identify phase more automated and data-driven, rather than just relying on spreadsheets and manual processes. If you're not fully in the Microsoft ecosystem, there are plenty of solid alternatives. Tenable and Qualys are great for asset discovery and vulnerability scanning. AWS Config provides a full inventory of your AWS resources, and tools like Varonis or Spirion can automatically find and classify sensitive data across your file shares and cloud storage. The goal is the same: gain visibility and know exactly what needs to be protected. Now that you know what you have, it's time to protect it. The Protect function is where most of your actual security controls live. This includes managing access, securing devices, protecting data, and training your people. Think of this as the preventive part of your cybersecurity program. It's about stopping threats before they can cause damage. Protect includes several key categories: identity and access management, awareness and training, data security, and protective technology. These categories ensure that only the right people can access your resources, that your employees know how to recognize threats like phishing, and that your data is properly encrypted and protected from leaks. Together, they form your organization's first line of defense. Microsoft offers a really strong suite of tools to help you implement the Protect function. Intra ID lets you enforce multi-factor authentication and conditional access policies. Intune ensures your devices meet compliance requirements before they connect. Purview DLP helps prevent data from being shared accidentally, and BitLocker encrypts your drives to protect data at rest. When these tools work together, they provide layered protection across users, devices, and data. Outside the Microsoft ecosystem, there are some equally powerful options. Okta provides strong identity management. CrowdStrike or SentinelOne offer next-gen endpoint protection, and KnowBe4 is perfect for ongoing security awareness training. Platforms like Google Workspace DLP and Symantec DLP help prevent data loss. The idea isn't to use everything. It's to build a combination of tools that fits your environment and security maturity. Even with the best protection in place, no system is 100% safe. That's where the Detect function comes in. This is all about identifying threats and suspicious activity as early as possible. continuous monitoring, logging, and analytics play a key role here. The faster you can detect an anomaly, the faster you can contain it and minimize the impact. Even with the best protection in place, no system is 100% safe. That's where the detect function comes in. This is all about identifying threats and suspicious activity as early as possible. Continuous monitoring, logging, and analytics play a key role here. The faster you can detect an anomaly, the faster you can contain it and minimize the impact. One of the best detection tools in the Microsoft ecosystem is Microsoft Sentinel. It's a cloud-native SIEM and SOAR platform that collects logs from across your environment. Azure, on-prem, Microsoft 365, even third-party sources. Sentinel uses built-in analytics rules and AI to detect suspicious behavior, and it integrates with automation playbooks so you can respond instantly. For example, you can automatically isolate a compromised device or disable a user account the moment an alert triggers. If you're in a mixed or non-Microsoft environment, tools like Splunk, IBM QRadar, or Elastic SIEM provide great alternatives. They can pull logs from multiple systems, correlate events, and highlight anomalies in real time. For smaller organizations, even open-source tools like Wazoo can provide solid detection capabilities without the enterprise price tag. The main point here is to have visibility. You can't respond to what you can't see. Once a potential incident has been detected, the next step is respond. This is where you put your incident response plan into action. The goal isn't just to fix the issue, it's to contain it, minimize the damage, and communicate effectively with everyone involved. A good response plan includes clear procedures, defined responsibilities, and automated workflows wherever possible. The faster and more coordinated your response is, the less impact an incident will have. Let's break down the respond function into its practical categories. First, incident management. This is your formal response plan and coordination mechanism that kicks in when something's detected. Second, incident analysis. Investigators dig into what happened, how far it spread, and what root cause led to it. Next, communication and reporting. Timely, clear messaging to internal stakeholders, customers, and regulators when required. Fourth, mitigation. The concrete steps you take to contain and remove the threat, like isolating devices or applying patches. Finally, improvements. After-action reviews and updates to playbooks, so the next incident is handled even better. Together, these categories give you a repeatable, accountable way to respond to incidents. Let's look at how we can actually respond when something goes wrong. Microsoft has done a great job integrating response capabilities across its ecosystem. Microsoft Defender for Endpoint can automatically contain threats by isolating compromised devices or disabling malicious accounts. Sentinel takes this even further with automation playbooks built on logic apps. You can script your response to common alerts so they're handled instantly, even at 2 a.m. This kind of automation not only saves time, it drastically reduces your exposure during an attack. If your environment isn't fully Microsoft-based, there are still plenty of great options for automated response. Cortex XSOAR and Splunk SOAR, for example, let you create workflows that automatically collect evidence, block IPs, or update tickets. ServiceNow Security Operations is another strong tool for coordinating incident response across teams. The key is to standardize your process. Every incident should follow the same clear steps: detection, containment, analysis, and communication. Automation just makes it faster and more consistent. Once an incident has been contained, the focus shifts to recover. This is where you restore systems, data, and operations back to normal. But recovery isn't just about getting back online. It's about learning from the event and strengthening your resilience. The faster and smoother your recovery process is, the more trust you maintain with customers and stakeholders. Think of this stage as your opportunity to turn a crisis into an improvement plan. Recovery is more than just restoring files. It's making the business whole again and learning from the event. Recovery plan covers executing your documented recovery plans so systems and services come back online safely. Improvements and lesson learned is about capturing lessons learned and turning them into improvements. This is where you close the loop. Recovery communications ensures stakeholders get clear updates about what's recovered and when normal operations resume. And don't skip testing and exercises. Testing and exercises validate that your backups and DR procedures work under pressure. Regular testing builds confidence that your recovery plan will work when it really counts. Microsoft has some excellent tools to support recovery. Azure Backup provides secure, point-in-time data recovery, and Azure Site Recovery lets you orchestrate full disaster recovery for virtual machines and workloads. The great part is that both can be tested regularly without affecting your production environment. When paired with proper documentation and communication plans, these tools ensure business continuity, even during major incidents. For non-Microsoft environments, you've got options like Veeam, Datto, and AWS Backup, which provide powerful data protection and disaster recovery features. What's most important here isn't the specific tool. It's having tested, repeatable procedures. Regular recovery testing builds confidence that backups will actually work when you need them most. It's one of those areas where being proactive pays off hugely in the long run. Let's look at CSF Profiles. These are one of the most practical parts of the framework. A profile is basically a custom snapshot of your cybersecurity activities and goals. You create a current profile to show where you are today and a target profile to show where you want to be. The magic happens when you compare them. The gap analysis highlights priorities and helps you allocate resources to the highest impact areas. Profiles are great for aligning security work with business objectives and explaining priorities to leaders in a language they understand. Implementation tiers help you understand maturity. They're not about compliance boxes, they're about how mature and repeatable your practices are. Tier 1 is ad hoc and reactive. Tier 2 is risk-informed but inconsistent. Tier 3 is repeatable with formal policies. And Tier 4 is adaptive and continuously improving. Use tiers to benchmark where you are and to create a realistic roadmap for moving up. Management cares about tiers because they show progress in a simple, comparable way. Now that we've covered all 6 NIST CSF functions, let's talk about how to actually implement them in your organization. Start by defining governance and scope, who's responsible and what systems are in play. Next, assess your current state using the CSF as a reference, then define your target state, where you want to be. From there, perform a gap analysis to identify what's missing and create an implementation plan to close those gaps. And remember, it's not about perfection. It's about continuous improvement. Here's what a simple implementation roadmap might look like. Phase 1. Focus on foundational controls like multi-factor authentication, backups, and user training. Phase 2. Introduce advanced monitoring, centralized logging, and automated response workflows. Phase 3. Build continuous improvement processes like regular risk reviews and penetration testing. This phased approach keeps the project realistic and helps you demonstrate quick wins to management early on. To make things practical, let's map Microsoft tools to the NIST CSF functions. Govern, Purview, and Entra ID. Identify, Defender for endpoint and purview information protection. Protect, Intune, DLP, and BitLocker. Detect, Sentinel. Respond, Sentinel automated responses using Logic Apps and Defender for endpoint XDR. Recover, Azure Backup and Site Recovery. This mapping shows that Microsoft's ecosystem can cover almost every area of the framework. You just need to configure and align them with your policies. And here's how that looks outside the Microsoft world. Govern, ServiceNow GRC. Identify, Tenable and AWS Config. Protect, Okta and CrowdStrike. Detect, Splunk. Respond, Cortex XSOAR. Recover, Veeam. This table proves that the NIST CSF is tool agnostic. It's about achieving the outcomes, not which products you use. Whether you're in AWS, Google Cloud, or hybrid environments, you can still follow the same principles. All right, let's wrap up with the key takeaways. First, start small and build gradually. Don't try to do everything at once. Second, focus heavily on governance. It's the foundation that keeps everything else aligned. Next, balance prevention, detection, and recovery. No single control will protect you from everything. And finally, remember that cybersecurity isn't just a technical problem. It's a business enabler. The NIST CSF helps you show leadership how security investments directly support business outcomes.